Let's get this show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1108. Let's see where we are here. So I didn't get to finish as much as I wanted to with the other class. So we're actually only going to do those two examples that I left you with last time because I was in between being very sleep deprived. So I'm moving extra slowly. And the fact that I'm trying to get used to new equipment. So, got a new tablet to write stuff on, and it's just, yeah, I haven't gotten used to it. Things moved a little bit slowly, but we are going to continue. So let's actually do that. We're going to go through those. Okay, there, I think that's good. We're going to go through those problems I mentioned last time. Where are we? Because that'll kind of set us up for chapter 5 tomorrow. Let me make sure I can see the chat here. All right, so quick recap. We finished chapter 3 last time. So the last thing we spoke about was summarizing all these formulas that we had come across. Okay, so there was the one-time lump sum formulas, right? So these are the formulas that we use when we make a payment one time and then we kind of forget about it, right? And it depends on how interest is being charged. So we look at the simple interest formula, the compound interest formula, and the compounded continuously interest formula. And again, I'll mention that if these guys show up in a problem, it's going to be stated which one you're looking for. And so you never really need to worry about when to use which one of these, because it's actually going to be given to you. So that's good. However, there's another situation, the multiple irregular payments situation. And so this is the situation where you're making multiple repeated payments over time, and the payments are equal, as we're assuming they're ordinary annuities, and the interest is charged at the end of each paying period. These are the formulas you can use to calculate those situations. So we have the future value of annuities formula and the present value of annuities formula. Now, we also saw when to use each of these. You use the sinking fund formula or the future values of annuities formula if you're saving up to something, and you use the amortization formula if you're trying to pay down a debt. So you have some future obligation that you want to meet, and so you're making payments to grow your money to a certain situation. You would use the sinking fund formula. If you have a debt you want to pay down, like a car loan or a mortgage, or you want to buy something and you know what payments you can make, but now you want to know what size loan you can get so that you can use those payments to pay down the loan, use the amortization formula. Okay, so that was that, right? Of course, these things can be mixed and matched in general, and we spoke about that as well. And that sort of ended our discussion on financial math, which is the very basics. It's just what's in our syllabus, and I would recommend that, of course, you guys become more interested than you guys apparently seem to be. I don't even see anyone here. More interested in financial math because it's important, and there's a lot more to learn. So you should definitely go forward more in this. And depending on your concentration or whatever, I guess if you're a finance major or something like that, you'll talk more about this stuff. But this is just the very basics of those kinds of calculations, and it starts us off on a very important journey. That being said, that's where the journey actually ended for us, and we wanted to, I think this was supposed to be 3 equations actually, because there were 3 things. So there are 3. Anyway, you guys can tell me what you got by trying to set these up. So I left you with a couple problems to work out, and the point of these problems is just to remind you about how systems of equations work, how to solve them, and that kind of stuff, because we're not really going to cover that, but it's actually going to be important to know that stuff for what we will be doing. So in in the first example, you just have to set up, because it's a lot more variables than I'd expect you guys to know how to solve at the moment. I wouldn't expect you guys to know how to solve a system with 3 equations and 4 variables. So that's that. And then in the other one, I do actually expect you guys to actually solve that in detail. Yeah, so that's what we're going to move on to now. So we're going to do these two. You can ask me any questions or maybe let me know what you did. And that being said, let's move on. So on the last episode, our heroes are faced with the following systems of equations problems. So it's these two guys. So now let's go. Let's begin. So this one is, and this is going to be somewhat typical. The word problems in this section, they're going to often be huge and hefty. Like this, there's this whole paragraph that you have to read and kind of figure out what to do. And so this one is going to get you used to that, how to interpret the word problems. But again, that's kind of something that I would expect you guys to know already, not necessarily teach you anything new, but hopefully you reminded yourselves over the weekend about how to tackle problems like these. Now, of course, whenever you have a problem like this, where it's just like very wordy, the first thing you probably want to do is to kind of do a summary where you pick out the important numbers. And a nice way to do that is via a table, right? So that's probably what I would do here to kind of just make sure that I have everything clear. So let's kind of figure out our situation. A farmer can buy 4 types of plant food. Each barrel of mix A contains 20 pounds of phosphoric acid, 50 pounds of nitrogen, 20 pounds of potash. Potash is a kind of fertilizer. It's like a potassium-based fertilizer. Each barrel of mix B contains 20 pounds of phosphoric acid, 75 pounds of nitrogen, and 30 pounds of potash. Each barrel of mix C contains 20 pounds of phosphoric acid, 25 pounds of nitrogen, 30 pounds of potash. And for mix D, we have 40 pounds of that. Okay. All right. So this dude has a field, he's a farmer, right? And he performs soil tests to indicate what his field needs in terms of nutrients to make sure that his crops are going to grow properly, right? So soil test indicates that 540 pounds of phosphoric acid is needed, 650 pounds of nitrogen is needed, and 720 pounds of potash is needed. Now we need to set up a linear equation that is going to tell this guy, via solving that linear equation, here's how many barrels of each mix you should buy so that you have all the nutrients you need for this situation. Okay, so that's kind of the situation. So X1 is the number of barrels of mix A, X2 mix B, X3 mix C, X4 mix D, etc. Right? So this guy wants to know if I have all this plant food mixes and these are their constitutions, like how do I mix and match them to get what I need for my field, right? So any random farmer can go into the store and see all these 4. How do they buy them? How do they mix and match them, right? So that's why he comes to us for help, the math people, right? So we're going to tell him how many things he needs to buy. Well, we're going to tell him what equations he needs to solve in order to figure out how many he needs to buy. So again, a nice way to do this is to kind of just summarize what's going on. So what I would do is maybe do a little table. So let's actually look at what are we doing? Different plant foods. Plant food. What? Plant food. Not sure why it's saying that. Okay, plant food. And what is in the plant food? We had phosphoric acid. We had nitrogen. And we have potash. Okay, now we have mix A, mix B, mix C, mix D, and let's put here the total. And the number of barrels of mix A, we're calling that X1, number of barrels of mix B, number of barrels for mix C, number of barrels for mix D. So this is number of barrels. Okay, so now let's actually just summarize how much we have of each. So we know for A, it has 20 pounds of phosphoric acid, 50 pounds of nitrogen, and 20 pounds of potash. For mix B, 20 pounds of phosphoric acid, 75 pounds of nitrogen, 30 pounds of potash. Mix C, 20, 25, 30. And mix D was 40, 25, 50. Right? So that's the combinations of each that we can get. Now, we have a certain total in mind. We want to make sure that we have 540. Right? So this is the total that we want. We want 650 pounds of nitrogen, and we want 720 pounds of potash, right? So this table here is pretty much summarizing everything that was in this paragraph right here, right? So that's a nice way to do it, to just kind of separate who has what amount of which nutrient, right? So A, that's how it is, B is how that is, and C and D, that's how they are, right? So I write a nice little table to just kind of get the numbers. At this point, you can get the equations from this. So if we kind of look vertically in this situation, I'm going to get the equations out of this. So that's going to be an equation, right? And this is going to be an equation, right? So I can have an equation that talks about the phosphoric acid content, the equation that talks about the nitrogen content, the equation that talks about the potash content, right? So what would that mean for us? Well, for the phosphoric acid, I know that for the phosphoric acid, this means for every barrel of mix A, I would get 20 pounds of that phosphoric acid. Plus, for every barrel of mix B, I would get another 20 pounds. For every barrel of mix C, I would get another 20 pounds. And for every barrel of mix D, I actually get 40 pounds out of the mix D. And the total I want this to add up to is 540 pounds. So this is the phosphoric acid requirements. Then we do the same thing for nitrogen and potash. So this would give us 50, 75, 25, 25. This is 650. This is the nitrogen requirement. Third equation, we'll talk about the potash requirement. That's 20. Uh, 30. Looking at that table, 30. And 50. And that should add up to 720. Potash requirement. Okay. Okay. So, and what that button does, but don't push the button. Okay. So that was actually the answer. Like this is all we were asked to do actually. So that was the answer. Just set up. Right. However, FYI, so in the old syllabus, I would expect you guys to know how to solve this, but I don't really expect you guys to know how to solve a system like this. But I would tell you what the answer is here. If we solve this, we get, you would end up with x1 is 9 minus t, x2 is t minus 5, x3 is 23 minus 2t, x4 is t. T, I would let range from 5 to 9, and it's whole numbers. We'll call them integers. Now, of course, I would want all of these guys to be greater than or equal to 0, and whole numbers. Right? So I can't buy -7 barrels of something, or I can't buy pi barrels of something, right? Sell me 1 over e squared barrels of this mixture. Like, you can't do that, right? So you kind of force it to take on whole number values. But the idea is here, this system here has an infinite number of solutions, but not all of them are practical. We only want the whole number solutions that can force us to buy a positive or 0 number of barrels for each mix. And it turns out that with that requirement, there are only 5 possible solutions. So this leads to the possible solutions. Is x1, x2, x3, x4 can be equal to, one possibility is 4, 0, 13, 5. That's like me plugging in t equals 5, right? Another possibility is 3, 1, 11, 6. That's if I plug in t equals 6. Another possibility is 2, 2, 9, 7. If I plug in t equals 7. Another possibility is 1, 3, 7, 8. So I plug in t equals 8. 0, 4, 5, 9 is what I get if I plug in t equals 9. Okay, so those would be the possible solutions. To answer the question that this farmer would ask us, under these conditions that I just gave you, how much of each mix should I buy? Well, there are 5 possibilities in this situation. You could buy, for example, 4 barrels of mix A, 0 barrels of mix B, 13 barrels of mix C, 5 barrels of mix D, and that will give you everything you need, right? Another example, 3 barrels of mix A, 1 barrel of mix B, 11 barrels of mix C, 6 barrels of mix D, etc. Right? So you can actually solve this and know exactly how much of each quantity, each type of mixture you should buy. There are 5 possibilities. Now, which is the best solution? Well, it would depend on the particular situation of the farmer or any other restriction. So maybe, for example, mix B is like super expensive. And so probably you'd want to go with a situation where you have to buy 0 barrels of mix B or maybe 1 barrel of mix B, right? So one of the first 2 solutions might be what you want. So additional restrictions can get us to cut the answers down a bit. But for now, those are the possible answers. You don't need to know how to solve this. You definitely need to know how to solve the 2 by 2 case, but here this is a 3 by 4. I won't expect you to solve that. You don't need to know how to solve this. Only special cases. Like the next example. So for the next example, we're going to solve that one actually completely. And I would expect you to be able to solve that completely. So yeah. But that's how we can do this. So you read a problem. One thing to do is to make sure that you fully understand the problem, where everything is going to go. So you can summarize your data somehow. Because of so much data was given here, I thought a table would be nice. So I summarized it in a table. And then I set up an equation for each column of that table. So I could talk about the phosphoric acid, the nitrogen, and the potash content all in different equations. For each barrel of mix A, I got 20 pounds of phosphoric acid. For B, it was the same. For C, it was the same. For D, it was 40. And I want the total to be 540. That leads me to the first equation here, right? So for every one of these guys, I get 20 pounds. For every one of these guys, I get 20 pounds. For every one of these guys, I get 20 pounds. For every one of these guys, I get 40 pounds. So we can get that there. Now, we get these three equations. In this situation, I would only expect you to be able to set these up, not necessarily solve them. If you can solve them, great, but it wouldn't be required for you to know how to do something like that by hand. Okay. Any questions on that one? Questions, comments, concerns? No, can't do that. Not sure why. No, can't do that. I can click on that. Both. Okay, so we don't have right click. Right clicking isn't a thing. Okay. Tap and hold and paste. All right, there we go. So this is the second problem. Why isn't right clicking a thing? Okay, so here's an example of supply and demand. Another thing that is very useful in people of our persuasion, the business people. So supply and demand, very important. And this is a problem about supply and demand. A very idealized problem, but it's an important problem to know how to tackle anyway, in principle. Supply is, of course, the number of products that a producer is willing to produce at a certain price. And the demand is the number of products that the consumers are demanding, or what the consumers would buy at a certain price, right? And so let's actually see what's going on here. At $4.80 per bushel, the annual supply of soybeans is 1.9 billion bushels. The annual demand is 2 billion bushels. When the price increases to $5.10 per bushel, the annual supply increases to 2.1 billion, and the annual demand decreases to 1.8 billion bushels. Assume price, supply, and price demand equations are linear. You want to find the price supply equation, the price demand equation, and the equilibrium price and quantity. So one thing you'll notice here is that this question does follow what is called the law of supply and demand, which basically says as the price increases, consumers are willing to buy less of a product because it's more expensive. They can't afford it anymore, or they'd rather spend their money on something else. And over time, as the price increases, producers of a product are willing to produce more of that product, right? So that also makes sense, because that means that there's more profit in it for them, right? So let's say I'm producing iPads or something. If I have to sell each iPad for $100, I'm not really going to be interested in making a lot of them, right? I have to go through all this trouble, hire all these people, get all this space, buy all this machinery, set up all this supply chain and stuff, and just for $100 a pop? No, not great. So if it's for 100, I'm not going to want to produce a lot, but people are definitely going to want to buy a lot, right? So of course they're going to want to, oh yeah, this is awesome. I can get this for $100. If the price rises though, it's like $1,000 a pop. Now suddenly I'm more interested in producing tons of this stuff. And people are a little bit less interested in buying it because they're like, well, I mean, it's $1,000. I could use that on something else, right? So yeah, so it turns out that the supplier is willing to produce more as price increases, while consumers are willing to consume less as price increases. And this is kind of called the law of supply and demand, right? And so you can actually see that here, that supply goes up when the price goes up, demand goes down when the price goes up. And we are going to figure out what these equations are and what the equilibrium price and quantity are. So let's actually do that. So let's do the first one. Okay. Mm-hmm. Yeah, this is why we didn't get as far as anticipated in the last class. Getting used to this system is okay. So let's go. All right, so A, let's talk about the price supply. Okay, so what I would do is let X equal price. Let's Y equal supply. But really, this is like just number of units. Produced. Okay, so what do we know? We know that we're assuming that this is a straight line, and we also know what points are on the straight line. How do we know what points are on the straight line? So let's go back here, and we realize that at 480 per bushel, the supply is 1.9 billion. At 510, the supply is 2.1 billion. So it turns out that for the supply equation, which is this blue equation that I'm going to be drawing here, those are the numbers. We have two coordinates on this. So for 4,80, we have 1.9, right? So I'm going to use this as billions of bushels. And at 510, 2.1 are on the line. Okay. So here's something, of course, I expect you to know how to do. If I give you 2 points, you should be able to find the equation of the line that connects the 2 points. So to find the equation of the line, one, we need the slope. Hopefully remember the slope formula, y2 minus y1 over x2 minus x1. This was the price. Let's call this x1, y1, call this x2, y2. Right? And so I'm going to go here, I'm going to plug in those numbers. So that would give me 2.1 minus 1.9 divided by 5.1 minus 4.8. That ends up being 2/3. That would be the slope. 2, I'm going to find the equation. Now, there are a couple ways you can go about this point. A lot of students know about the y equals mx plus b version. And so what you can do is you can plug in the x and the y and the m, solve for the b, and then go back and get the equation. Or you could use something called the point slope formula. Equation via point slope formula, which is my personal preferred method. So that's like the y minus y1 equals mx minus x1. Now the x1 and y1 just represents an arbitrary point, so I could actually choose x2 and y2 here. That's not the point. So what I would get here is I can plug in, say, y minus y1, which is 1.9, equals m, which we just found is 2/3, x minus 4.8. So that's the line. We can rewrite. This would look like y equals 2/3 not used to writing on this thing yet. 2/3 x, and I believe this is minus 1.3. That's in the slope intercept form. But what I'm going to do is I'm going to actually rewrite again into another form. It turns out that I can take this guy here, and knowing that 1.3, I can write that as 13/10. I have two fractions where the denominators are 3 and 10. So what I can do is find the LCD, which is 30, multiply both sides by 30. This will kill all the fractions, and I can rearrange after that. So what I did here was multiply by 30 and rearrange. Right? And I can rearrange it in this form, 20x minus 30y equals 39. This is so-called standard form. More convenient for us. Okay, so I'm going to take that to be the equation. Okay. But yeah, these calculations I would expect you to be able to do. Similarly, we can do this for the other part. We can do a price demand equation. Maybe let's do that in the red scenario. So I'm not going to go and create a table here because, I mean, the sentences weren't that long, so that kind of overkill, but I do want to make sure that I'm looking at the right thing. So I know at 480, now I care about the demand. So that's 2 billion. And at 510, the demand becomes this. Okay. So that's what I'm doing here. So turns out, if I let, again, x equals price, y equals demand. Again, this is going to be number of products or bushels. Then we get that 480 comma 2 and 510 comma 1.8 are on the line. We're told it was linear. So what I'm going to do is I'm going to find the slope. y2 minus y1 over x2 minus x1. I'm going to plug in those numbers. And that became minus 2/3 in this scenario. So then I go with y minus y1 equals mx minus x1. And that leads to me getting the following. Y equals minus 2/3 x plus 5.2. And again, what I did was rewrite this thing as 20x plus 30y equals 156. So again, multiply by 30 and rewrite. Get that. Okay.
Why are you multiplying by 30, Professor?
To write it in a nicer form. I want to write it such that I have all integers, so I don't have any fractions or decimals. And so what you realize is that this here is like y is equal to minus 2 over 3x plus 52 over 10. Because remember, one decimal place just means divide by 10. So the LCD is 30. And so what happens is I can multiply through by 30 both sides. And if I do that, I would have 30y minus 20x plus 52 over 10 times 30, which that now becomes an integer, right? That becomes the 156, and then I rearrange it. Now, the reason I'm rearranging it is because it's a convenient form to have it in, and you're going to notice why this is convenient. I mean, at this point, you would say probably this is the answer, but you'll see in part C that it's nicer to have the answer in the last form that I just used. So moving on to part C, this is talking about the equilibrium price and quantity. So this is getting at the notion of what's called market equilibrium, right? So for you to kind of see an idea of what I'm talking about. Let's say here we have price along the horizontal and we have quantity along the vertical. We have like a supply or demand. Right, we're going to plot them both on the same graph so you can kind of see what I'm getting at. So we know that if I have at $4.80 and we have data for at $5.10, right? So I know for the supply at $4.80, suppliers are willing to supply 1.9. Right, so that's that right there. Right? And at $5.10, they're willing to supply 2.1, it looks like. So say, I don't want to actually fill that in like a point. So let's say 2.1 is here. So they are like so. Right? So what this question is assuming is that the function here is a straight line. Right? And that's the supply equation. And then you do the same for the demand. So for the demand, at 480, people are actually willing to buy two. However, when the price increases to 510, they're now only willing to buy 1.8. Again, assuming that the equation here is a straight line. That's what that would look like. Okay. So this is demand. Right. So this is the law of supply and demand. Demand will decrease with a higher price. Supply will increase with a higher price. Now, of course, there are a couple things that you will notice. Notice that there is a point here where they intersect. Now that point is super important, right? You'll notice that to the left of that point, what we have is something called scarcity. Why is there a scarcity? Well, look where the supply and demand are. Suppliers are supplying 1.9 billion, but people want to buy 2 billion. So we have people in the market who want to get 2 billion of this stuff, but there's only 1.9. It's scarce, right? So there's not enough supply to meet the demand. This is called scarcity. However, you'll notice that on the other side, like if you look from this point going forward, you have like surplus or excess, right? Notice that over here, the blue curve is on top of the red curve. People are willing, producers are willing to make 2.1 billion of these units, but people are only willing to buy 1.8 at this price. So what you have is you have a market where the supply exceeds the demand, right? And so you have more products in the market than people are willing to buy. So you essentially have some products sitting on the shelves that no one's buying, and it's just a waste, right? This is just excess, right? Neither person wants either of these situations, because on one hand, in scarcity, the people producing the product could be making more money than they're currently making. Why not make more? Whereas in excess, the suppliers are like, we're making all these products and no one's buying them, so we essentially wasted our money, right? Versus, again, in the scarcity situation, people want to buy the stuff, but there isn't enough, right? Like, so that's not desirable. Or people don't want to buy and there's extra stuff. They're like, man, there's these things are everywhere and I don't care. I want the cheaper one, right? And so neither of these are desirable. What we desire is this situation that is called market equilibrium. This is where supply meets the demand. And this is a very idealized situation, as I mentioned, but linear supply and demand is used sometimes. And this is how you would actually figure out how to price things and how much you want to actually produce. And so what we can do is, for example, we can test prices in different locations. So I can sell it for $4.80 over here. I can sell it for $5.10 over there. I can sell it for $5 flat over here. I can sell it for $4.25 over here. And I create a curve, a function that connects how many do I sell in each location. And I can come up with a supply and demand curve, just like this. And the goal is to find the perfect price and the perfect amount to make so that we make enough and we sell all of them. And so we make as much money as possible and we don't waste anything. And the consumers are happy because everyone who wants to actually buy one can get one. So that's good. That's called market equilibrium. We want to find the price here. So geometrically, we want to find the intersection. Curves. Algebraically, what this means is solving a system of equations. Algebraically. And we know the system of equations. We actually found them earlier. So that is, we know that 20x minus 30y is going to be equal to 39, and 20x plus 30y is going to be 156. This was the supply equation. And this was the demand equation. Now you can see why I wrote them in this form, because now you can hopefully see that the process of elimination or solving systems of equations by addition becomes immediately useful. I can add these two. I would end up with 40x. The y's would cancel, and I would end up with 195. So this means that x is equal to 195 over 40. That's roughly $4.88. And so now, by plugging into either equation, just because I'm going to plug into the second one, I can plug in that x value. And I can solve for the y value. Turns out the y in this case is going to be 39 over 20. So this means the perfect price to sell it at is $4.88, and the perfect amount to make is 1.95 billion bushels. So this is billions of bushels. This is the price. And overall, this is the equilibrium price in quantity. If we sell it for this price and make this much, we won't have scarcity or excess. Everyone's happy. And we can obtain that by solving a system of equations. Right? And so this problem is one that I would expect you to be able to fully solve from start to finish, right? This one, no, too many variables and too little equations. Here, I would expect you to be able to set up a 2x2 system and solve it to find a certain point. This is actually going to be needed for where we're going. So that's the prereqs for chapter 5. Now, yes, I didn't actually teach you guys how to do this, but that's because 1, it's not in our syllabus. 2, I would expect you to know how to do this from previous classes, like a algebra or pre-calc class. You start that next class. But we're going to be doing more on top of this. So we are going to need to be able to do this in order to do something else. So this is just going to be the first, just one part of a larger problem that we are going to want to solve. Did the same thing. Start with 5.1 tomorrow or next class. So we will stop there. That's it. So just a couple examples to get you used to the idea of setting up systems of equations, solving them. That's going to be necessary. But in the next section, we're actually going to make this even a little more complicated. We're going to be looking at situations like where we don't have an equal sign. What if we had a greater than or equal sign and this were a less than or equal sign, right? What do we do then? How do we find the solution then? Turns out that it's not as straightforward as this, and we will get to that. So, yeah, that being said, I think we will stop there. Let's see here. Okay. Thank you for your attention. We will stop there. Hope there are no questions. And with that, I guess I will see you guys in the next one.